Alright, I'm going to make a video reviewing over some of the concepts involving converting a polar equation to a Cartesian equation and vice versa. And then we'll do a couple problems about area in polar equations. So hopefully this will be a pretty short video. So let's start with 85. We have r equals 8 cosine theta plus 4 sine theta. So let's multiply both sides by r, so we get this r squared 8r cosine theta plus 4r sine theta. And we're doing this because we know that this is equal to y, and this is equal to x, and this is equal to sine squared plus cosine squared. Or not sine squared plus cosine squared. It would be x squared plus y squared. Right, from this equation of a circle. So now we can rewrite our equation with the left side as x squared minus y squared with 8x plus 4y. Then I'm going to set one side equal to 0. So we'll get x squared minus 8x plus y squared minus 4, minus 4y equals 0. And now we want to put this into a form like x squared plus y squared equals r squared. So we're going to complete the square for these ones. So if we have two negative 4's, that'll add up to 8, but then a 4 times 4 is 16, so we want to subtract a 16 to keep it all equal. Then if we have two negative 2's added together, that'll make a negative 4. This can be y minus 2 squared. And then we want to keep it equal, so we're going to subtract a 4, because negative 2 times negative 2 is 4, and all that equals 0. So now let's add our integers over, and we get x minus 4 squared plus y minus 2 squared equals 20. And this will be our answer for that first question. So let's go to the second one. We have r equals 1 over 2 cosine theta plus 4 sine theta. So I'm just going to multiply this over to the r side, and then we'll be left with 1 on the other side. So when we do that, we'll get 2r cosine theta plus 4r sine theta equals 1. And we know that this is x and this is y, so we get 2x plus 4y equals 1. And we can just solve for y and divide by 4. We get 1 minus 2x over 4, or 1/4 minus 1/2 x. And that'd be our answer for this one. So a lot of the strategy here is just recognizing and manipulating equations into forms that we recognize. So let's erase and try this last one. Hey. So this is the polar equation given, and we want to manipulate it into a Cartesian equation. So how do we approach this one? If we convert x squared into r cosine squared and y squared into r sine squared, then we can, if we multiply this out, this would be r squared cosine squared plus r squared sine squared. So we can pull a common factor of r squared out of each of them. Now we're left with cosine plus sine, those are both squared, equals 6x. Well, we know that this is a Pythagorean identity, so that's all just equal to 1. And then we can set this equal to 6x. And we know that x is equal to r cosine. So then let's divide both sides by r, and we end with the polar equation r equals 6 cosine. So we started with a Cartesian equation, ended with a polar one. So my general strategy is identify the equation that's given. So in this one, we have all x and y values. So I should only really be converting my x and y values to the polar equivalent, which are these r cosine, r sine. And then if I'm going the other way, we have more equations to work with, right? We have, I guess it's just the inverse of the other equation. We have x is equal to r cosine. So I want to manipulate the equation in such a way that I can get something that looks like that to get my x value. And then it just involves completing the square afterward.